Right, how are you? Today we are going to look at the properties of the Laplace transforms. The properties of the Laplace transform. We are going to start with them today. So, the properties of the Laplace transforms. We are going to start with them today. Right. The first property that you are going to do here, it is called the linearity property. Right, linearity property. It states that if f of t and g of t have the Laplace transform and C1 and C2 are any constants, then the Laplace transform of C1 f of t plus C2 g of t, which is the same thing as C1 times f of s plus C2 g of s. Now, we need to prove this thing is true. How would you prove this thing? Proof will be provided. Then, we will say that the Laplace transform of C1 f of t, the Laplace transform of C1 f of t plus C2 g of t, it is what? It is equals to what? The integral of C1 from 0 to infinity of C1 f of t plus C2 g of t all times e to the power negative st dt. By the law of integration, we know that integration is working linear, which means you can take this and multiply it inside, right? You can do that. So this times that, this times that. So in this case, now I'm going to have an integral from 0 to infinity of C1 f of t e to the power negative st dt plus an integral from 0 to infinity of C2 gt e to the power negative st dt. Right? And we know that if we can take it out C1 integral from 0 to infinity, we are going to have f of t e to the power negative st dt plus C2 times an integral from 0 to infinity of g of t e to the power negative st dt. By the law and by the principle, you know that the integral from 0 to infinity of e from negative st times f of t dt, this is what? This is the same thing as what? As f of s, which is the same thing as the Laplace transform of f of t. All right. So, what we are left here in this step, we are left with C1 f of s plus C2 g of s. This is the final answer. So we have proven the linearity principle of this thing. Right. So what does it mean to have the linearity principle? It means that you can take the Laplace transform of different functions by adding them. So an example will be, let us take the Laplace transform of 1 plus t squared minus cos 3t minus 1 over 7 sine 7t. Sine 7t, like that. So what we can do, we can find the Laplace transform of each of these functions. So the Laplace transform of 1 plus the Laplace transform of t squared minus the Laplace transform of cos 3t minus 1 over 7 the Laplace transform of sine 7t. Right. What is the Laplace transform of 1? The Laplace transform of 1, that is going to be 1 over s plus, what is the Laplace transform of t squared? That is 2 factorial divided by 2 to the power, 2 divided by s to the power 3, minus, what is the Laplace transform of cos 3t? The Laplace transform of cos 3t, it's going to be s over s squared minus 9, minus 1 over 7 in bracket. What is the Laplace transform of sine 7x? It's going to be 7 over s squared plus 49. You can simplify this further to be 1 over s plus 2 over s cubed minus s over s squared minus 9 minus 1 over s squared plus 49. You are advised that do not find the common base in the Laplace transform. Do not find the common base to the Laplace transform. Just leave it as it is. But the purpose of this video, it's not looking at the linearity property, looking at different functions. In this example here that we are doing here, we are focusing on trigonometric functions. We have rules here. So any person who will get this video will understand that certain trigonometric functions need to be applied to get the Laplace transforms. Do you understand that? So the first one is that what will be the Laplace transform of sine squared 3t minus 7 cos squared 2t. In the Laplace transform of trigonometric variables like this one, it's not this thing here, guys, it is the z transform, but just say this is the Laplace transform. I've just written that symbol wrong. So let's just keep it as a Laplace transform. So how would you calculate such a thing? You will be provided, in your note, you are provided with something that has some trigonometric and hyperbolic function definitions. So you need to use the thing as wise as possible. So whenever you need to find the Laplace transform of sine squared 3t, just know that there is no Laplace transform of sine squared 3t. The first thing that you need to admire here, it is you need to write the double angle of cos that satisfies this. So if you have the sine cube, sine squared 3t, you need to rewrite this thing as what? As 1 over 2 in bracket 1 minus cos 6t. You are only going to find the Laplace transform of a trigonometric function if the exponent of the trigonometric function is what? It is 1. You cannot find the Laplace transform of a trigonometric function that has an exponent more than 1. Right? So bear that in mind. So there you are going to have cos squared 2t. you need to write it as 1 over 2 in bracket 1 plus cos 4t. So this is how you're going to find the Laplace transform. So you're going to find the Laplace transform of what now? Of 1 in bracket 1 over 2 in bracket 1 minus cos 6t minus 7, the Laplace transform of 1 over 2 1 plus cos 4t. So the half would go outside. I'm going to have 1 over 2, the Laplace transform of 1 minus cos 6t minus 7 over 2, the Laplace transform of 1 plus cos 4t. So it's 1 over 2. What is the Laplace transform of 1? The Laplace transform of 1, it is 1 over s, minus, what is the Laplace transform of cos 6t? It is s over s squared plus 36. We are done with the first bracket. Minus 7 over 2 in bracket. What is the Laplace transform of 1 again? That is going to be 1 over s plus, what is the Laplace transform of cos 4t? That is going to be s over s squared plus 16. So you may simplify or you may not simplify. Do you understand that? But the common ground here is that first, find the Laplace transform or try to figure out the trigonometric definitions around this thing here. And the questions will be sent to me via the thingy, the comment sections. And then number two, find the Laplace transform of 4 sine 2t sine 3t. You cannot find the Laplace transform of two trigonometric functions that are multiplying each other like that. So what is the best way of doing that? You need to write the product of the trigonometric identities. You need to remember this. You need to remember that if you say sine A cos B is equals to 1 over 2 in bracket sine A plus B plus sine A minus B. You need to remember this formula, by the way. And then, by doing that, we are going to have two separate functions that you can take the Laplace transform of. So by doing that, I'm going to have the Laplace transform of 1 over 2 in bracket sine 2t plus 3t plus sine 2t minus 3t. So the half will go outside. I'm going to have a 2 times the Laplace transform of sine 5t minus, what is the Laplace transform of sine 2t minus 3t? That it is minus sine t, like that. And then now you need to find the Laplace transform of that. You need to find the Laplace transform of that. So whenever you have functions which are multiplying each other like that, make sure that you separate using these rules. So the second one, So I'm going to have 2 in bracket. What is the Laplace transform of sine 5t? It is 5 over s squared plus 25 minus, what is the Laplace transform of sine t? It is 1 over s squared plus 1. Like that. So we have found the Laplace transform of this function as you see it here. Right, so this will be your answer in a nutshell. Right, And then number 3, the Laplace transform of sine t minus cos t all squared. Since the sine and the cos are all squared, first you need to simplify the inside of the bracket. So by doing that, I'm going to have the Laplace transform of what? Of sine squared t minus 2 sine t cos t plus cos squared t. So by simplifying the sine squared and the cos squared and this, I am going to have the Laplace transform of 1 minus sine 2t. Like that. It's simple, yeah? So because we have sine t minus cos t all squared, you first need to simplify the inside of that bracket. After you've simplified that inside of the bracket, you can collect some or use some trigonometric identities. You can just really see this is a double angle of sine. This is a double angle of sine theta. That is a double angle of sine t. So just keep this in mind that trigonometric identities, you need to play with your maths. Play with your maths here. So in this case, we're going to have in bracket, what is the Laplace transform of 1? It is 1 over s minus, what is the Laplace transform of sine 2t? It is 2 over s squared plus 4. Closed bracket. So that's the answer. You see, it is very easy if you are going to do it in this manner. And then number 4, let us find the Laplace transform of 4 cos 7t plus 3 minus sine 7t minus 3. How can you find the Laplace transform of that? Now, you cannot just find the Laplace transform of that as it is like that. The reason you cannot do it, it is because this is a compound angle, man. This is the compound angle. So you need to write down the compound angle of sine. You need to write down the compound angle of what? Of cos. So in this case, you're going to have 4, the Laplace transform. What is the compound angle of cos? The compound angle of cos that has a plus inside, it is cos 7t times cos 3 minus sine 7t times sine 3 minus in bracket. What is the compound angle of sine minus? It's going to be the sine of 7t cos 3 minus cos 7t times sine 3. Like that. Sine 3. You can see that you can take out the common factor. This and this have a common factor. This one and that one has a common factor. They have a common factor of what? They have a common factor of cos 7t. Anything that is multiplying cos 7t, it is just a constant. So we are going to have 4 times the Laplace transform of cos 7t in bracket cos 3 minus sine 3, and then minus 7t in bracket sine 3 plus cos 3. Like that. So where now you are focusing on a function that has a variable of t. anything that does not have a variable of t, you are taking it as a constant. Do you understand that? So you are going to take it as a constant. Anything that has a variable of t, take the Laplace transform. But something that does not have a coefficient or that does not have a variable of t, do not take the Laplace transform. So it's going to be 4 in bracket. What is the Laplace transform of cos 70? It's going to be s times that constant of cos 3 minus sine 3 divided by s squared plus 49. Minus, what is the Laplace transform of sine 70? It is 7 in bracket sine 3 plus cos 3 divided by s squared plus 49. You can add these together because they have the common base of s squared plus 49. They have the common denominator. But I think you may just leave it here. This will be your answer. So just keep in mind that I'm just going to give you here number 5, that the Laplace transform of sine 6 is the same thing as sine 6 over s, because sine does not have a variable t. If it had the variable t, it's going to be different. But because 6 is a constant, which means sine 6 is in radians. That 6 is radians. So it is a constant. So your answer is going to be sine 6 over s. So I think that I've made myself clear. You are not going to have any problems regarding the linearity property coming along with the trigonometric identities. So please make sure that you do simplify first and then. Now let us do the last one. The last one is going to be, it's going to be quite handy to do, but we'll do it. You are going to do it with another procedure by simplifying it. The one that I'm going to do now, please do it using this method here. Me, I'm just going to use it with definitions. Number 5. The Laplace transform of sine t minus cos t squared. The procedure that I'm going to do this is to write down the definitions of each. The definitions of each. We know that sine A, it is e to the power a minus e to the power minus a divided by 2, and cos A, it is e to the power a plus e to the power minus a divided by 2. So if you add them together by finding the Laplace transform, you will see that I'm going to have 1 over 2 e to the power a minus e to the power minus a minus e to the power a minus e to the power negative a. All of this squared, there is a square that I have missed there. So I'm going to have, if you square the half, I'm going to have 1 over 4, the Laplace transform of e to the power, because these will be like terms. Then I'm going to have negative 2 times e to the power negative a. but now odd squared. So it's going to be 1 over 4, the Laplace transform of 4 e to the power negative 2a, like that. Now the 4 will go outside, then I will have the Laplace transform of e to the power negative 2a. Now what is the Laplace transform of that? It's going to be 1 over s plus 2. You use a, I've used a, but it's t, by the way. I just made that mistake there. So it's going to be 1 over s plus 2, like that. So this will be your answer. So this is how you use your Laplace transform in the linearity principle or property. See you on the first shift theorem.